Okay. So today we are continuing our journey, let's say. So far, no questions about what we have seen last week. Maybe you had time to take a look, think about stuff, or no? No question? Okay. So we can continue then with structures in Rust. So before we start, an important thing you have to know is that Rust is not an object-oriented programming language. I have the feeling it's kind of a tendency right now not to go for OOP. For instance, Golang as well has made the choice not to do an object-oriented programming language. And but we will see that thanks to many constructs we have in the Rust language, we can achieve basically the same goals as object-oriented programming. So we are not basically speaking of objects in Rust, but rather we are speaking about structures and enums, and we are going to start to talk about structures. So, yeah, for those who have done C and C++, yeah, it should not be like that hard to understand the concept of structs and structures. So this is the way basically you define a structure in Rust, sorry. So the keyword struct, the name of the struct, curly bracket, then you define the structure members. So here we are defining a rectangle. So we decided to put two members, one of the being the width and one being the height of the rectangle. Just a small note about this that you see on top of the struct. Basically, every time you see like how you call this hashtag square bracket something inside and yeah, a closing bracket. This means this is a procedural macro, a Rust macro, and those ones are different from the ones we have seen with the bang, because those ones are actually Rust code, pure Rust code that is basically processing the Rust AST, and that which does some stuff under the hood. So in this case, when you see derive something, this is something you are going to see a lot in Rust code. This just means it implements a trait. A trait is more or less an interface. We're going to see that later. So it's implementing some methods for the struct rectangle. And in this case, we are implementing the debug trait. And the debug trait, what it is, it's just making possible to use this question mark format parameter in println and format method. If I just remove this line, for instance, we are going to see that it's complaining here. It tells me rectangle doesn't implement debug. The trait needs to be implemented. Okay, so it's not like just you can make some abstraction about this. I'm just explaining it right now because it might be confusing and you might ask yourself what is this? So yeah, just implemented some methods on your behalf. You can, of course, remove this and implement the method by hand, but this is much more convenient relying on the debug trait. You can always do it manually if you want to implement some custom formatting, for instance, and stuff. The the debug trait default implementation doesn't do. So, for instance, we could imagine that we want to print this structure plus additional data. I don't know, like the area or some stuff. We might need to implement like a custom method, a custom debug trait implementation. So when we want to instantiate a structure, nothing more simple. We can do as we did for variable definition. So let variable name equal, and then we put the name of the struct, curly bracket, the values we want for the fields, and then we close everything and we terminate the line. And when we want to access the members, not so confusing. I guess it's a notation we can relate to the other languages. It's like the struct instance. So in our case, it's R dot to access the member. So in this case, width and height. We can take those values, for instance, to compute the area of this rectangle, and we can print it. So I think it's pretty simple so far. Nothing that should be problematic. Just tell me if that's okay. Yeah.
So the bug, right?
Yes.
It's only for the bug, basically, because it's called the bug. But
It,
do you use it also in production, this production?
this is just for format printing.
Yeah.
So I mean,
Why it's only in the bug?
because the debug trait, if you want, look, when we do the run, the debug trait shows like the struct like this.
Well,
So basically, it's like printing all the information about the struct. And this is something that you can, that basically you want for all the types. You want debug information to be somehow like that.
We will not need it for normal.
Yes, but you always implement it because it's very convenient when you need to debug. It doesn't mean you need to use it. Yeah, this is something important to understand is that as Rust is doing like lots and lots of stuff at compile time, it's not because the code is there that it's going to cost something. So if you implement debug and you don't use debug trait in your code, I mean, at compile, it's dropped. So it's not because it's there in the code that it's going to cost something at runtime. So yeah, basically, this is almost like something you do every time you create a struct. Is like derive debug because at some point you will need it. And yeah, there are some other traits that you implement like a lot as well, like the clone trait that we have seen previously with the strings, for instance. This is a trait that can be derived in this way as well, and yeah, basically you use it almost by default. So another way to define a structure, it's called a tuple structure. In case you need maybe some very simple and straightforward structure. This is not like a notation I would recommend for very complex structure because I mean there is no information about the struct members, for instance. So here we define a rectangle and the members, we could say that they are anonymous because they don't have a name. And in this case, we say that the first one is the width and the second is the height. And the way we instantiate such a structure, this is the same notation as a tuple, instead that we put like the name of the structure before. And we access like the structure members the exact same way as a tuple. So yes.
Is there any reason to use double structures instead of cluster structures? It's less declarative and more important with that.
To be honest, sometimes I use it when I have one or two members which are very obvious, but yeah, this is something I almost never use personally. And I've never seen it like used to encode very complex structures, because of course you need to keep track of like, okay, index 0 is that, index 1 is that. It's a bit.
Of memory performance.
No, it doesn't change anything. Doesn't change anything. Because yes, in the end, it's going to be compiled to something very similar. It's like first item is U32, second item U32, and so yes. So this is tuple structure, not very complex to understand, just a notation to remember, and that knowing it exists. There is also unit structure that you can define. It's basically a struct that contains no member. This might be used, for instance, when you just need to get more or less a placeholder and you want to just derive some methods for this structure. But that's very rare, I would say, to use such a structure. The only one I know is from a library which is called Pest Parser. And basically you define a unit struct like this, and you just derive a trait which is parser, and it generates all the methods for you. And I mean, you don't need to have members or whatever. It's just like an object with which you can actually work. So this is pretty rare to see that, but again, it exists. So don't be shocked if you see just structure without nothing. Yes, in this case, yeah, interesting. Here, I'm implementing a trait, basically. It will be like a very gentle trait introduction. So when you want to implement a trait, we are going to see that later, don't worry. It's like keyword imp, the name of the trait, and then you say for the structure. And here, what I'm doing is I'm implementing the display trait. And the display trait is just something that allows us to use the format string. So, and here, when we are going to format unit struct, it's going to write, this is our unit structure. So here we should see US equal, and it should say this is our unit structure. Again, if this imp block is like confusing for you, don't worry too much about it for the moment, because we are going to see that in the next chapter. Is that clear? Okay. Now,
So to be able to define our own custom structures, we need first to implement that, not define this implementation of the before.
If you want to
call it up.
Yes.
The name. Yeah, unit struct.
Yes.
This is necessary to be able to implement display in struct.
Yes, of course, because if you don't define the struct, you will just say, okay, you implement a trait for something that doesn't exist. Cannot find type unit struct.
It's like an import.
What?
The struct, the directive that we.
This?
Yeah.
No, this is not an import. This is a structure definition. This is a struct definition. It's like, have you ever done any C or C++? So you just declare the structure, and there maybe the stuff which is confusing is that there is no members. This is just a struct without any members.
And then you implement display
Yes.
based on display, right?
Based on?
On display.
Yeah, display is a trait that you need to implement for any type that you want to be formatted in println or format macro. Otherwise, it's not gonna work. It's just going to tell, okay, look, if we don't implement display, it will tell us here required by this formatting parameter, unit struct doesn't implement FMT display. So this is what we actually implemented, and it complains about it.
So display is the default construction or structure or trait. What is the display?
Display is just to be able to format the structure inside a format directive.
How do you call display itself? That input display that we implement it, let's say override, not override, but we inherit kind of.
Pardon?
Display. We inherit display.
It's not inheritance. There is no concept of inheritance in Rust.
I know, but kind of.
No, this is a trait implementation. So a trait is like a shared behavior between objects, structure, not objects, between structure or enums. So this is something that you need to implement in order to be able to do something. This is not inheritance at all. This doesn't work. It doesn't exist in Rust, inheritance. This is purely object-oriented programming stuff. So yeah, but don't worry too much about this. We are going to see that later. Field init shorthand. The only thing to know here is that when you have variables with values already defined, so again, we defined a struct as we did previously, nothing new here. When you have variables which are defined with the same names as the member of the struct, you can basically use them when you create a structure without saying width like this and height like this. Okay, this is what you would need to do in many other languages, but here it just tells you that it's completely redundant and tells you like replace it with width, and here replace it with height. This is just like basically init shorthand, that's what they call. Just to know that if you see that, I mean, it should not shock you. Just to know it exists again, and we see it.
So if it was A and B, we should specify
It's
like a key of the.
If I rename this one A, it even like do it for me, you know? It does it for me. And this I do, I rename it to B, same.
And the order is important in the declaration of the
No.
members?
No.
Yes, since you specify, you can say the height before the width.
No, there is no issue. The only requirement is that, but that means it's super obvious, is that the variables are defined before the struct.
Yes.
Otherwise, it's not going to work. Yeah, I will just
it doesn't do
this.
the auto rename on my side. Is it like a module that you're using? Like if I just change the name,
no,
it
it
doesn't
should
do it.
work. It should work with Rust Analyzer in theory.
Oh. Okay, yeah. Like if I just change the name, it doesn't change it. So I don't know.
Do you do F2?
No. What is F2?
Yeah, you need to do F2 to rename.
Oh, okay, I see. Yeah, right. No, it
It
works. Yeah,
doesn't work?
Doesn't
it does. It
request,
does. With F2, it does.
for me, it's fine, doesn't complain.
Maybe because as I set up Clippy last time, maybe it's Clippy complaining.
I
So
mean,
this
with
was fake.
F2, I have no problem. It's just, yeah, like I don't have Clippy installed.
With F2 it works,
It does work with F2.
Raphael?
Yes. Yes, it does.
Okay. And let's see if who is actually complaining. Mm, yeah, look, what it tells me is that, and when like
Right.
the linting start with Clippy, it
Hmm.
means that it's Clippy who does it and not
Right.
cargo check. So if you guys didn't configure Clippy as
Hmm.
a checker, you are not going to see this error. In
Right.
case you want to configure Clippy, I will just show you. It doesn't take a while. You go in the settings, either a user or workspace as you wish, and you search in the settings for check. And then you can go in Rust Analyzer, check. And here, instead of check command, you just put Clippy like this instead of check. You should see check and you replace check or nothing. I don't know. Maybe by default there is nothing. If you want Clippy, basically you just put Clippy here and you will get like the same warnings as me.
But this is
Right.
not error. This is just a suggestion, right?
Yes, this is a suggestion, but
For style.
yeah, many Rust projects, I mean serious ones, have like strong Clippy warning checks in the CI/CD. So, and most of the time is like refuse any warning and consider it as an error. And so that's why it's always better to fix the warnings as early as you can, basically. So yes, many projects are checking the code with Clippy, and if you have like with stuff like this, it would like refuse PRs or whatever. So that's it about Clippy. Small parenthesis closed. And now, if you do something like this, you should see a warning. And we can go quick fix, replace it. Okay. Next is struct update syntax. So again, nothing new. We still get our rectangle struct. We instantiate one in R1. Let's say we want to create another instance of a structure copied basically from R1. So we could do like this. R1.width, R1.height. And there is a shortcut that you can do in Rust. It's just like this. It's just rectangle, you put dot dot R1. Means I want all the fields, all the members, all the values of the fields from R1 into my structure. And you can even do like partial. You can define some members and you say, okay, the rest is going to be the one from R1. So we can verify that. So R3 should be the same as R1, and R4 should be different from R1, having width 10 and height 10. We can just run the test. And yes, that's what we said. So yes, this is a notation you are going to see. I wouldn't say like a lot, but You should see it in Rust code, especially in default implementation, because you have a trait to implement. Two, if you want to create a default value for your structure. So you might see this notation when you create, for instance, a new instance of a rectangle from its default value. This typical notation. So for instance, I will just show you. I implement the default trait. Yes.
Tu peux tester, normalement celui-là il est monitor là. Au cas où tu peux tester sur toi, celui-là je suis moins sûr. Par contre. Ouais.
So I implemented the default trait, and the default trait, what it does, it just takes the default value for each field and will set the structure with the default field values. So what you would typically see, and that's maybe most of this notation that you will see is like this. This is what you would see. 99% of the case. It just means you take the default value. This is a method which is exposed by the default trait. So now we implemented the default trait. This method is defined for our structure, and this just provides a default structure, rectangle structure. And this notation, you would see it for this in this use most of the time. But again, don't worry too much about these traits and method and so on. It's going to be more clear when we are going to see that in a trait chapter. If like the notation confuses you for the moment, just make abstraction of it. And now we should see R5 being 0, 0. Okay. So just for you to be comfortable with this syntax. So now we are going to talk about something we have seen last Friday, which is ownership and structure. So any structure own its data. So when you create a struct, it takes ownership of its field. And when the struct is dropped, all its fields are dropped too. If some fields are borrowed, the compiler needs to know that every reference is still valid until the struct is dropped. So you might need in this case to handle lifetimes. And maybe I will try to craft a sound lifetime example, maybe for today or the next time. Now we have seen struct. I will try to replicate a kind of issue you might be facing with structs and lifetimes. So all this ownership and lifetime and so on, again, I repeat, it's to guarantee, to satisfy the guarantees provided by Rust. So the fact that you cannot have like race conditions and so on, mainly. You cannot have double free, you cannot have lots of bugs you see in other languages. And for instance, here is an example. So the ownership rules behave the same as we have seen last week. So if we take, for instance, alice.name from the structure we have just defined on above, so the person structure, with the string Alice as a name and age 42. So if you remember correctly, last week we have seen strings is allocated on the heap. String doesn't implement copy, so it cannot be copied. So when we do something like this, what Rust does is taking the strings and moves ownership to the variable n. So what does it mean concretely? It means that if we want to reuse some fields from Alice after, it's going to complain. And that's what we can see here. If we uncomment this line, the compiler tells me borrow a moved value, alice.name. Moves occurs because alice.name has type string which does not implement the copy trait. Exactly tells you the thing. So it tells you value moved here. It even hints you where you move the value. So this is great and interesting. Does anyone remember why this works and we don't get the one in here? Because?
Yeah.
Because yes, it's a primitive type and the primitive types implement copy. So here, actually, there is no a move from age into the variable a. There is no ownership takeover for a. It's just like copies the value age and put it into a. So
I
yes,
have a question just a bit above of the declaration of Alice.
yes.
Why don't you just use the quotes and say Alice? Why do you use string colon from Alice?
You mean this?
Yes.
Oh, sorry. What did I do? So this we have seen, it's not a string type.
It will
This
be
is a
yeah,
string
type.
slice.
Yeah.
So if I want to do that, I have to do that.
Yeah.
And this means concretely that I can instantiate a structure of persons only with static strings.
Yeah.
So it's a bit like restrictive, let's say in your programmatic approach, because you cannot like manage dynamic string names or whatever. So this is basically something you will rarely see in applications. You might do something like this, which is nice, but you will need to put some lifetime, I guess, somewhere. This is weird that it's not complaining actually. Yes, it does complains. Missing lifetime specifier.
But I'm not one.
So yeah, this would be a very efficient implementation of persons because you don't redefine a string every time. But yeah, again, it depends on the use that you make of this structure. And it's a bit maybe advanced to see that right now because it's mixing like lifetime structures and so on. And yeah, most of the time you would get like a string here. And string from. And things get even more complicated in case you want to mutate the string. So you would need to put like a mutref here. So yeah, that's I would say it's advanced struct definition because it's mixing like several concepts that we have seen and yes, again, it depends on the use case, but in this case, I'm pretty sure that if a program would have to define a person struct, it would define it like this with a string type here. Okay, so what could we do to fix this? There is a simple one that doesn't take much resources and one that takes resources.
Clone?
So clone takes resources, yes. This is going to work because I'm cloning the string. I'm creating a new string from the existing one, copying memory. This is the costly one.
And you just use new for it. That is ownership of transfer too. For N should be used instead of Ali's name, you should use N.
Where there?
Yeah.
No, it's not going to change anything.
Really?
Yes, it's going to change. Yeah, it's going to change. Yes, it's going to work. But I mean, this is not like the fix I want.
If we could give a reference of the Alice name to N.
Yes, this is going to work.
If you do some strange things, then yeah, why not?
Of course, if you flush the test completely, it works as well. So yes, this is the good answer actually, because here, if we just want to print the value or we just want to use the n value, there is for read only. There is no reason to copy the strings or whatever. It's just good to take a reference to it. So yeah, this was just to illustrate the ownership and the struct. So now, how can we define methods on a structure? Because that's what we want, right? We define our rectangle struct the same as the beginning of this exercises. And the notation is like this. You have to use the IMPL keyword, the struct name, and then a curly bracket to open. And this is like a whole block where you can define all the methods related to your rectangle. When you want to take a rectangle object in your method and use its fields, you have to use the self keyword, a bit like in Python, right? Don't mess up with this. Most of the time you are going to see methods with ampersand self, because what happens if we put self without the ampersand? Any idea?
It's the file.
Yeah. So if we put self without the ampersand, this method is going to take ownership over the structure. And then when you go out, poof, no more struct anymore.
Yeah, so it will be
Yeah. So we will see there are some use cases where you put self without the ampersand. But for, I don't know, getters, setters, eventually methods, yeah, computing stuff and so on. Yeah, all the time, don't forget to put the ampersand. So this is how we define a method. I will just try to see something. Okay. Ah, yes. Okay. Just wanted to see if I need to talk about something or if it was mentioned or if it is mentioned later on. So here I will just put a return here so that we don't go below. We should see the area that we compute. And here, this is how we call a method, and especially a method without any parameter. Here, there is no parameter except the self value, and the self value is like here. So we don't need to use any parameter. Our area equal 15. And this is correct. 3 multiplied by 5 equals 15. Something I don't mention later is that this is a notation that you need to know, a syntax you need to know, because sometimes you need it. You can also call a method like this. So you take the struct name, semicolon, area, and R. This is another syntax that you can use. Basically, you say I call the area function method from struct rectangle with ampersand R as parameter. This is another way to call it. Of course, in code, I would never call the method like that. But there are some use cases where you need to specify function calls like that. In maybe advanced cases, but don't be shocked, it exists.
Does it mean that we can call a function like this with a structure, not type of rectangle?
No,
No.
no, this is impossible because here is this means area defined in struct rectangle. So, and rectangle and area methods just expects a rectangle as its first parameter. So you can put a string here, right? But it's going to complain, of course. It's going to tell me
Object, right?
it's going to tell me expected reference of rectangle, and I get a string. So I'm not happy. Okay, so let's move on.
And sorry, can you create a one-liner to that instantiate the rectangle and call the area function?
Yes, in this case, it might work. Let's check. Yes, in this case it works. It's not going to work in all the cases. Here it's an exception, I would say, because here we return directly a computation from the two fields. But yeah, it might not work in all the cases, but yes, you can do that. Yeah, let's keep it. So, thing to know, you can have, if you want to organize your code in certain way, you can have several imp blocks. So here we redefine a new one where we define a new methods for the rectangle structure. So you can have as many imp block that you want. Maybe you might have one for private method, one for public method. There is no like consensus about this, but I mean, just know that you can do that.
Right? So it does not overwrite. It's not one block. You can have several. Like
Yeah.
They
Yes.
all the methods.
Yeah, you can define. I mean, you define it at several places if you want, but in the end, it's seen as a single one. It's like the only thing you cannot do is like redefine a method with the same name. It's going to complain about it. If I redefine here area, it's going to tell me that okay, area methods already exist. Yeah, it's telling me here, but duplicate definition of area. So yeah, only thing you cannot do is redefining a method that already exists. So here it's basically a modifier method that takes a parameter width and actually replace the width of the rectangle with the given parameter. So now we had like width 5, so we should have an area of 30, right? After we modified. Okay, that's what we got. So
in this case, you put mutable on self.
I put mutable because I need to mutate. Yeah, good question. Very good question. I forgot about mentioning it. So yes, when you do need to modify the structure that you, I mean, if the method is actually touching, modifying values of the structure, you need to put a mute self. So it's a reference to a mutable version of self. So don't put, sorry, don't put mute self everywhere. Otherwise, you are going to get trouble. And I think even if you put mute self and you don't actually mute the stuff, it's going to complain. It's just going to be it should just be a warning. No.
With the underscore, it means it's not used. It
Yeah.
cannot be. It can not be used.
Yeah, it's just like to shut the compiler mouth, basically. Yeah, I don't know why it doesn't complain, but yeah, in theory, it should complain that you use mut self and you actually not mutating the value. Sometimes it does it. I don't know why it doesn't do it now. But yeah, you should put mut self only if you are mutating the structure.
And so for the area function, we will have, if we want to create a self area,
Yes.
we will have to set a mute self, and then we would be able to have a self area
I don't get your question.
to create a area parameter for the rectangle,
You create a area parameter
a new parameter,
and what do we do next?
and print it. I don't know.
Okay.
Like,
But you cannot add the parameters in Rust. It doesn't work like this. It works only in Python and stuff like that.
you have to define it
Yeah.
initially.
Yeah, this is like completely forbidden. This is not possible. Because this structure, it needs to be known at compile time, and I mean, you cannot add fields like in JavaScript or in Python or whatever. It's completely impossible to do that in Rust. You cannot add fields on the fly. you define structures and then they are fixed for all their lives. I mean, in the compiled program. So yeah, we can try. It just tells you, okay, you try to modify something that doesn't exist. I will not use area because it's a method name, but it's just going to tell me, okay, do you want to modify something that doesn't exist? No fields on type, so. Okay. Interesting. Next example. So I'm defining a new implementation block of rectangle. And here is an example of a method that takes ownership over the structure. And this is like a use case that you would see in many Rust programs and even in the standard library. These are methods which usually start with into, let's say, string, prefix, into prefix. And this is basically a method that takes your structure and turns it into something else. And here, in this example, we just take our structure and we put it into tuple. We convert it into a tuple. And why is this interesting to take ownership over a structure like that? It's interesting because actually, when you turn our structure into a tuple, in this case, if you think about it in terms of the Rust ecosystem and the way ownership works and so on, it doesn't require any new allocation, right? New memory allocation just takes values which are already existing and just turns them, change the layout basically of the structure. So this is like very well optimized in the way that it just changing the way a rectangle is interpreted after that call. And that's it. It doesn't cost anything in terms of allocation and so on. It's just like, let's say, compiling and structure interpretation changing. So as this method is taking ownership of the rectangle structure, there is no way that we can reuse the instance of the rectangle after we call this method. And that's what we can see here. We do R into tuple and we print it. All fine. We should see rect tuple somewhere. Rect tuple 10.3. Okay, it works. We have converted it into a tuple. And now, what happens if we do that? If we just... Ooh. Okay, why don't you want to let me uncomment? Okay. Of course, this doesn't work because we try to borrow a moved value of R, and it tells us that it moves due to this method call. So into tuple takes ownership over R. So it's it's just like the self structure goes into this function but never goes back. And that's why it doesn't work. So again, we could fix that, but this is not the goal. We could clone or doing some stuff like that. This is not the goal. This is just to show that even methods you define on structure can take ownership over the structure. And this is like such an example of the into family methods which are converting a structure into something else. And you can also define a structure that don't take self as first parameter. So this can be seen as a, how can we call that? Static methods maybe, or constructor in this case. This is like a more constructor. Look, it doesn't take any self first parameter. It just take, for instance, a tuple and then create a rectangle structure from it. So this is like a interesting notation. We could put here return a rectangle, but you can, in Rust, you can use self instead. It just means the structure you are defining. This is not like the same self as we put here because it's like uppercase S. It just means you can see this capital S self as this struct name. Okay. And same if you want to instantiate a struct, you can use the self keyword instead of the structure name. It's exactly the same as this. This is just a notation that exists. You need to know, and don't be shocked about when you see it's it works. It's just shorter than to write self than the structure name everywhere. This is just for sake of laziness of the developers, I think. And maybe have more readable code. Especially when you have maybe some very complex structure or structure name. And here, how do we call a method like that? Exactly as I call the area method at the top, sorry, is name of the struct. This is like a namespace separator in Rust, so you will see it like in imports, you will see it everywhere. So it means you take the method from tuple defined in the rectangle structure, and here I take one parameter, and the parameter I take is this. So what I'm doing here is just I convert R into a tuple, and then I take that tuple and I convert it back to a rectangle. Straightforward. And
Can I ask a question?
yes, tell me.
When there is no self in the arguments of the method, you cannot call it with dot notation, right?
No, because actually you don't need a rectangle instance to create a rectangle from a tuple.
Okay.
So you don't need to put a self keyword as the self first parameter, because simply it's useless, because you don't need a rectangle instance to create a rectangle instance. That's what we do here. We take a tuple and we create a rectangle instance.
And in this case,
So you could see this as a constructor.
Yeah, no, I understood, but I just wanted to know if I can call R dot from tuple, and there is an error, a compilation error on this.
Yeah, you cannot. You cannot, because it doesn't take any rectangle instance as a first parameter.
Okay.
So you need to call it from the path, let's say, of the function, and yes, this is like how I can call that. Maybe a static method is like the terminology in other languages, right? is like you take the path of the structure and you call a method associated in of that structure. It's just like an associated method that you can use, and it belongs like to the rectangle structure. We could even put it outside, but I mean, it would be a bit more confusing, you know. Here we clearly say it's in the rectangle structure that we can create it from a tuple, and that's it. And typically, what many structures have is like you have like the new function which always return self, and you just create a new instance of a structure. I would need to use default in this because, and this you would call, maybe it's simpler like this, no, to figure out. No, isn't it?
Yeah.
This is how to create a new rectangle from the new methods, for instance. And here the only difference is that it's let's say a bit more complex, I would say, because the parameter is not like empty. It's just we take some values to initialize the structure. But yeah, you cannot call like R3 dot from tuple. This is not possible. It doesn't even exist. It doesn't even exist because there is no yeah, this is not like a method you can call with a rectangle instance.
Can we make it without new method, creating some structure new instance without actually,
Without the new method?
Yeah.
Yeah, that's what we did so far. I mean, we did like.
Is default head way?
Pardon?
Is default head and way? So head 0 way.
Yeah. I don't understand what you mean.
We can define the structure default parameters. So we create structure weight U32, height U32, but can we define 0, 0? Also, by default, they are 0.
Ah, yes, we can do that. That's what I did like with the default trait implementation on top. If I put like if I derive default here, that's what it's going to do.
No.
And yes, I would typically do that. And here we see again the notation. And okay, maybe this is a bit weird for you to understand right now, but why do we do all this? Is that we didn't talk about this, but so far all the methods we have defined are all private. And you have to manage all these API privacy and stuff in Rust. So everything we define so far is private because there is no keyword, but you can do like this, and this is like a public function, and yeah, the function that you can use from outside. So meaning this would be in a library, for instance. You could reach it from a project that imports this structure. And yeah, so in Rust you have to manage the visibility of everything. So the structure, the function, the method implementations, and so on. You have to manage all this visibility. This is not like super hard to understand because it's a concept which is completely shared with other languages. Just few keywords to know, which is pub to publish it to the external. You can make it public only for you create. So you create is like, for instance, it's visible inside your library but not outside. You can it can be public inside a module. No, I thought it would be. Okay, I thought you can. It's like this. Self is only public inside the module where it's defined, I think. But yeah, I mean, this is not an in. I don't remember what is in. This is not like super complex to figure out. It's just a few keywords to know. And yes, that's about it. Is that more clear now, this notation, or not? Or it's like still confusing for some of you? It's okay? Yeah.
Is it possible to kind of like daisy chain those method calls for rectangle? Like you can say rectangle new, and then double column into tuple, double column from tuple, you know, because
No, you cannot, because because this is like a method call that returns an instance of a rectangle. And if I take an instance of a rectangle and I put like double column, I mean, it's going to tell me what the hell are you trying to do? It's like exactly as doing, I don't know, R1 and trying to reach. Yeah, this is not like an instance. This is like you have to see it as an import.
Yeah.
This is an import. Maybe it's less confusing. This is an import of the rectangle structure, and you call the method, which is called from tuple, from this import. This is a static method. This is a method which is defined inside rectangle, but this is not an instance of a structure. This is really an import of a type, of a type. It's like, yeah, static method. You have this. Yeah, I guess you have this in Python, Java, in all the stuff, and you always like put the name of the type, and then maybe it's dot in Python and in Java, and the function. It's just that instead of dot in Rust, the namespace separator is like is a colon, double colon. That's it. But this is an import. You have to see this as an import. Tell me, Ruslan.
Any create objects, not the create extend structures.
No. No possible. This is not OOP, Ruslan.
But we can emulate this.
There is no concept like this. You can work around, you can do stuff that achieve the same goal, but this is different concepts. So most of the OOP behaviors, you will not find them in. Maybe the only stuff that is close to object-oriented programming is the concept of trait, which is very close to interface. But that's the only thing that is close to object-oriented programming. The rest is like doesn't exist.
Can you repeat the implementation of default you did? I missed it.
The derive?
The default.
This?
Yes. So the implementation you.
It's this. It's just you have to put default here in the derive trait. And this under the hood again, what it does, we can do it only quickly for the purpose of the exercise. What it does is just imp default. This is the terminology for trait implementation. So you say, I implement the trait default for type rectangle. You type fn, it will propose you the method you need to implement. And then you say self width 0, 8, 0, And this is going to do exactly the same. And Clippy is complaining because it tells me, hey, this imp can be derived. You are dumb or what? Just like you can put just one keyword in the stuff and you write like 7 lines of code. So yeah, this is what the derived trait is doing. It is generating this code. Okay, you just don't see it, but it exists when you just put like derived default. And you might ask yourself, but how can he know the values for the default? Because every basic types and so on have a value for defaults and just takes the default value for every member. If you have a member in your structure that doesn't implement default, it's going to complain. It's going to tell you, hey, dude, you have like a field there in your structure that doesn't implement default. So, I mean, I cannot know what is the value for that one. So, yeah. So, one thing to remember about derive is that if any of the members doesn't derive itself the trait, it's not going to work. It's going to complain. The compiler is going to complain about it. But again, we are going to see that more into detail in the trait chapter. And yeah, default implementation is just doing that. The default derive trait. Okay, it tells me, okay, just do derive default, and that's it. So you see, it's helping you a lot, like the Rust Analyzer, telling you when you are dumb or not. So this is very helpful. Finally, last exercise, if we want, you can create a circle structure. So let's do it together. Don't forget to put E at the end. And there is only a radius. Radius, maybe we have to put a float. Might be more interesting because if we want to compute the area, we will need a float for sure because we will need to use the pi constant, so which is a float and not an integer. So impl circle. This is where we are going to implement our functions. FNU.
Yes, we complete implementation for new, for area, for set variables.
It's because you use Copilot. You are cheating.
Yeah.
And your code will even don't work. So to compute the area, we don't need to be mutable. So
need to spell R in the previous use radius.
What?
This radius we reformed not circle R.
Ah, yes, yes.
cell
Yeah, I can put
I
that.
decided.
So the pi constant, you can find it either in this package or yeah, maybe let's do a small stuff. We will use like the full name of the pi constant so that you know how imports are working. So std, yeah, I don't remember. std f64, std f64 const pi. So this is basically an import path of something. So this is Rust standard library. We go into f64 const pi. Just maybe it's the good timing to talk about the standard library. We will see that when Firefox will be ready. Let's implement that and then we see, okay, area is pi multiplied by r a o is that correct? Pi r square? So, as I said, there are many libraries, functions for types in Rust. So there is one for raising the power of a float, which is comes in two variants. There is pow_i and pow_f. So pow_i expects a integer as parameter, and pow_f expects a float. So yeah, that's about it. So here I chose the pow_i because I don't need to specify a float. So fn so here for the radius modifier, we would need to to mutate the structure itself. So we need to put a mutable reference to self as a first parameter. And finally, a method that say can hold. So this is our circle. We can put like order. And that returns a Boolean. So let's do it simple. Since we don't have the coordinate, self.r greater than other than r. Right? Is that correct? So we can do some tests. Let C1 equal circle R with a radius of 3. C2 with a radius of 2. So
When we call this array,
pardon?
when we call this array by default, I mean, just create new object.
Yeah. Yeah, we can, yes, I can call with radius, of course.
By default.
No. I have to do that like this. Yes, I create a constructor that I don't use, of course. Okay. So we can do some assertions. We have C1.area equal assertion, let's say. This should be equal to by multiply by 3 OI2, right? This should be okay. C2 should be the same, but with 2. This is just the way that usually you test stuff in Rust. When you implement your test, you just put assert stuff everywhere. And there is like this macro, which is assert ec, which asserts that two values are equal. So here I'm just asserting that the value out of the area function equals like to the value it should be equal to. If now I say assert C1 should be able to hold C2 because it has a smaller radius, C2. And now if I do C2.set radius to, I don't know, 5, now it should not be able to hold C2. So I should put like a negate condition. Yes, 5.0. It's complaining because I'm trying to mutate C2 and it's not declared as mutable. Okay, let's see if our tests work. Yes, it works.
Find or constants.
Yes, this is like a constant.
Because for me it says that you cannot find it.
Yeah, this is Copilot. No. You have to import it. The stuff auto imported it for me, like the Rust analyzer. I typed py and it like auto imported it here. These are the use directive on top. You can always use the full path of the constant. That's what I did here. There. This is the same value as here. So everyone managed to make this small exercise? Is anything complicated about it? Is anything shocking, disturbing? Question that should be answered? I think
I've got an error, I create a cycle, and after that I call set radius,
yes.
and then I print the cycle,
Mhm.
and I get
In theory, you cannot print it because there is nothing that implements
yeah,
print directive.
I get that the value has been borrowed here after no. Tell me. That's
Yeah.
the issue.
So C, better you create it with radius, you derive debug, okay, and copy with radius because there you take ownership. You didn't put the ampersand. So set radius takes ownership of the circle and you need to put it before the mute. Yeah. And now it works.
Okay, thanks.
Does it work?
On ne compare les structures. I will put an error on that, the C, set radius, we said.
What's the issue?
Radius.
C as mutable. This is because you need to define the variable as mutable as well.
Yeah.
Now it works.
Yeah.
So a small parenthesis about the Rust standard library. Where we can find information about types, APIs, and blah, blah, blah. That's the page, basically. And okay, you don't need to read all that. These are all the primitive types. If you want to know, I don't know, the method you can use on F64, here they are. And all the methods are here. So quite a lot, right? Basically, there is Rust has made the choice to have like very, very, very well furnished standard library for vector manipulation, string manipulation, integers and float manipulations too. So basically, there is almost everything you want and you need in this standard library for the basic types, for vectors, for strings. So if you are looking for, I don't know, string, you can, yeah, there is this search bar on top. You do search, you put string, and there you get like the struct definition, and you have like all the method for strings as well. So yeah, I invite you to take a look to those. In the end, when you know some of them, most of the time you are always using the same functions and same APIs. So in the beginning, it might be long to find what you need, but once you know it exists, I mean, just reuse it everywhere when you need. So yeah, that's about it. And if we
documentation is on that STD.
Yes, this is the Rust standard library. Interesting to know. Well, maybe it's a bit early to talk about that because Rust can run in context where there is no allocator. So there is no library to allocate memory. And this is usually in the core crates, sorry. So in the core crate, you will find all the types and all implementations that you can use in a context where there is no allocator. So might be embedded systems, might be the kernel, might be stuff like that. And STD is everything you can use where there is an allocator, and you get all these types such as vectors, strings, and so on. Basically, stuff that can grow in memory. So yeah, this is VEC. So this is the vector type implementation. And if you look at it, you can do like really a lot. You can sort it, you can convert it to the stuff. You can shrink it. You can truncate it. You can do like really a lot of stuff with it. And the idea of really well furnished standard APIs is that just people rely on trusted and efficient functions rather than implementing their own. So you can be pretty sure that everything which is in there is like very well implemented and produce very efficient code. Okay, so let's move on to the next chapter, if there is no question. And the next chapter is about enums. So enums might be a concept which is a bit more complex to understand, because it doesn't look like the C enum, and I don't think there are similar constructs in other languages. But this is very, very, very powerful, and you actually really need to understand it, because it's at the core of Rust, and it's really making your life easier once you understood it. So basically, how I can summarize a enum, it's kind of a superstructure that can be of different kind. And this is the key to implement some sort of, let's say, object-oriented programming patterns. You need to understand enums. So this is a very, very, very simple enum. This is how you define an enum keyword, enum name, and then you define the variants. These are called the variants. So I define an enum which is shape kind, and I define basically two kinds. That's what it means. I define a circle kind and a rectangle kind. This is mostly C-style enum definition. So this is why I start by that, because it's maybe the most simple for the one who already did some C-lang. And in order to use a enum variant, we use like the kind of namespace import like notation. So it's like enum name, double colon, and the enum variant. So in this case, what I do, I define a circle shape kind. That's why CK. And there I am defining a variable holding a rectangle shape kind. That's why RK. We can just run the test, and CK should tell me CK rectangle and RK, CK circle and RK rectangle. So enums are, as I said, like struct. So you can implement methods on enums. In this case, we create like two dummy constructors, let's say, one creating a circle shape kind and one creating a rectangle shape kind. And instead of like calling the variants by themselves, we can just call the methods. And we get exactly the same output. Is that okay so far? So that's now that stuff becomes more complicated. So most of the use of enums that we do in Rust is with data carrying. These are called data carrying enums. So every variant is able to hold some data. That's why I said like I kind of consider it as superstructure, because actually every variant can be kind of structure itself. So for instance, in our example of implementing geometrical shapes, we could create a shape structure that can be of three kinds. That can be a dot. A dot doesn't need any parameter, right? Assuming we don't need the coordinate. It's just a shape. Without like position in any space. A circle, which just need a radius, and a rectangle that needs a width and a height. So yeah, and there we have all the, basically we cover all the syntax we can get about enum variants. So like variants without any parameters. One variant described as a tuple, because yeah, we don't really need to use struct-like notation. And one variant that uses the struct-like notation, the rectangle, and which is basically the one we defined in all the previous exercises. And simple, that's how we define different instance of shape. So might be a dot. So we just take the name of the enum, double colon dot. We can define a circle, shape, double colon circle, and the value for the radius. And a rectangle, and we instantiate it almost as we do for a structure. And we implemented debug for the structure, for the enum, so it's able to print it nicely for us. So this, in my last iteration of this training, was very confusing for the people. So is that clear for you guys? Okay. It's kind of yeah, a bit mind-blowing, like the fact that you can have different variant completely with different layouts. But yes, the best way I really managed to explain that is that, yeah, you really have to think about an enum as superstructure that can be different kind of structure. And here already, maybe you can already infer the kind of OP pattern that you can replicate with such a mechanism. And interesting thing, and what you would see in many cases, maybe just wait. Yes, okay, I'm just speaking about it in the next exercise. Pardon? You mean having enums inside enums? Yeah, sure. And that's what we are going to see here. This is basically an alternative implementation of the previous example, is where we define structure, clear structure, and in the shape enum, instead of defining a radius here and a struct-like notation here, we use like structures that we define above. So the rectangle structure and the circle structure. And to relate to your question, Andrash, so this could have been an enum. I mean, enum and structures is almost like you can use them almost interchangeably. So this could have been an enum. I mean, we could create, I don't know, enum square. And what do we put as variant? Tell me. Small and big. Okay. Small and big. So we could have like a square here, and we use the square enum inside. And here it's complaining because we don't implement debug. And here is like, if you type F12, it's like, yeah, this enum.
If you wanted to create a square, it would be shape square and then the shape smaller.
If you want to create the square outside?
Yes, inside of it, yeah. So like below we select the S shape dot.
Ah, okay.
So it's similar to that if it's nested.
So tell me what you want to do.
The big square, yes.
Let big square. What do we do with the big square?
So shape, square, and then big, right?
No, you have to put square again and big, because this is like the enum variant and this is like the enum name. This we could put S. You see, it has nothing to do like this. Doesn't need to be this, but most of the time in the patterns you will see in code would be stuff like that. It replicates the name. And many times what you would do, but it's a bit advanced, you would implement, for instance, the from square for shape, and you do self, because we are in a shape, and you put value there. And you would do, this is like a trait that convert any square into a shape. And you would do maybe something like square dot big, and or either you do like, because there it wouldn't know like in what you need to convert it. So if I do this, it tells me, okay, I don't know in what kind of stuff you want to convert it. So I would need to type it like shape. And there it converts square shape, a square big into a shape. This is powerful. He understood. So yes, this would be a typical use case of this. But again, this is like a trait implementation, a bit advanced for the moment. But yes, this would be a typical use case of enum in practice. Is like you have your enum, you put like some custom types in it, And you can even have like conversions functions between the types and the enums. But you see that the contrary might not be true, that you cannot convert a shape into a square without issue. So we would have to implement another trait which would be called try from for the backward conversion if we wanted to do it. So, but this again is a bit advanced. So yes, and that's how we may instantiate shape variants. Okay, the methods, I mean, the way we instantiate would be a bit redundant because we have circle, blah, blah. And in practice, we would rather do like implement shape. And we would do, I don't know, fn circle and r. And what we could even do, but this would be a bit like a bit weird to do. We could even say we could implement like the from trait for F64 if we wanted, you know. So when you have a F64, you want to turn it in a circle, it would be easy to do. So this would be self.circle and circle R. Why does it complain? Because it's not the good type. Yes. Because I put a U32. Okay. Okay, so this would be more practical, let's say. You want to create a new circle shape because yeah, this notation would be a bit heavy to put in your code. So you would create like intermediary methods like this. Okay, is that clear? Yes. So this again is just an alternative notation to the alternative way to implement, let's say, not notation because we implement like intermediary structures of this example. And to be honest, in practice, 99% of the case, you will rather see this rather than this. It's more flexible, let's say. Yes?
I have a question. Can
Tell
you,
me.
sorry, can you re-explain why we need to pass circle to circle to create a circle?
Because this is the enum variant name, okay?
Eh?
This is the enum variant name that we define here. And the enum variant holds a circle structure. So we define here a variant of circle, but to define to instantiate a circle variant, we need a circle structure. So this is like the circle structure that is inside the circle variant. But as I said, this is like we could call this I don't know, potato.
Okay.
This doesn't need to be related to the circle, okay?
Okay.
This is just what you see most of the time in practice because yeah, because as I said, you can see a shape as a super struct holding different kind of structs, and most of the time you call the variant of your enum as the same name of the as the structure. Just for sake of simplicity, basically. So first, this is like enum variant name. Ah, damn it. This is enum variant name, if I manage to select it properly. The first one, even variant name. And second is what you need to put inside the variant, which is a circle structure. Is that clear, Andrea?
Yes. So to create this, I would call shape column circle, and then I pass
Yes.
the radius.
Yes. Yes. If to call this method, you mean?
Yes.
Yes. Yes. Yes. We can do it. Instead of this line, we could do, let's yes equal shape. It would simplify a lot the notation, right?
Mhm.
It's exactly the same as this. If we do like CS1 and CS2, yeah, but I cannot do equal. They are. I cannot like do assert ec because the method, I mean the enum doesn't implement the equality trait, but you see that both stuff are the same. This is just like an example, a practical, let's say, a example of how you would actually use a shape in practice. You would very rarely use this notation as is pretty ugly, right? And you would prefer creating an intermediate function with the parameter for your structure. Or you could even, like, I don't know, you could just create a circle, which is let C, and you do this. And you put C there. If it's like more readable, you can do that. And don't forget that enums and structs takes ownership. So this cycle would be ownership would be moved to the enum. So if we want to do something with C after that, we are doomed. This
Okay.
is not possible. It's going to complain that the stuff has been moved. Okay.
Yeah. And next question is, of course, we are not talking about OOP, so we cannot create a basic shape and then all the other shapes inherits from this shape. But
No.
can we do some kind of a common function inside the shape? So, for example,
Yes, and that's what we do. That's what we do here, and maybe that's what we do after. Yes, we are going to see that after.
Okay.
Don't worry. But yeah, anything that you define in the imp shape. So here is like a kind of constructor, so it's a particular case, but every method where you will put self as a first parameter will be like a shape enum. So it's going to be, you're going to be able to handle the case of dot, the case of circle, the case of rectangle, and the case of square every
So
time.
there will be something like self variant or self. I don't know
Yes.
what. Okay.
Yeah, self. We will see that.
Okay.
Because before that, we have to introduce something new, but I think we are going to take a break before you guys like overheat. What do you think about it? Okay, so let's see in 45 minutes. You guys remote?
Yep, all good for
Okay.
me. Yep.
Okay, great. See you later.
See you later.
See you later.